Welcome. I'm Bill Wake. We're here working on a Kaleidoscope for iOS. And one of the challenges we've had is that the boundaries, well, the way we work is we take a piece of pie and we move it all around an image and reflect it so it looks like a kaleidoscope view. The challenge is sometimes our pie appears to be off the boundaries to the top or the side or the bottom or something, and getting into white space outside it, which means the white space gets reflected, and in fact, it can make it completely disappear. So we've tried multiple ways, and without great success, other than feeling like, oh, I think I got it now. You know, I've had that feeling 5, 6, 7 times. Maybe X is right at this point. We kind of think so. I kind of think so. So we'll just refactor slightly on the X. Yeah, coordinate system draws down from 0. Yeah, so I think upper half. Yeah, so I think that's what we were trying to do on what is today? Tuesday. On Monday, yesterday. Our last try was something like this: size.height over 2 plus that times scaled sine. So scaled sine is well, sine is -1 to +1. Add 1 to that, it's 1. Sorry, it's 0 to 2. Divide by 2, it's back to the range of 0 to 1. Okay, so multiplying by scaled sine 0 to 1 times the height, well, divide by 2 is 0 to 1/2, times the height is 0 to up to half the height. Okay, and this size.height divided by 2 is putting it down at the start at the center of the screen. So the sine needs to be in the bottom half of the screen, which is the top half of the coordinate system. Yeah, so what I do to get the radius is I take the minimum of width and height. So we get a square, and that gives us the height of the piece of pie that's going to go do it. Let's see. So let me pull up a couple old pictures, and so here's like the original photo, and then if you oh, I guess I did this as an animation. So let me take the minimum bound to make a square, and then I take one piece of pie, going down vertically from the 0 y to the center, and x horizontally across to the center, and then it's actually a circle radius, not a bump like that. But that piece is what controls it, and then it gets reflected and then repeated. Okay, but wow, darn it. Okay. The challenge we have is, where is the center of this thing going to be? Well, we're going to move that around the image. And so what we've realized, I mean, Mudshark666 pointed out yesterday sometime, like, hey, if you're trying to keep this to half the height of the radius, the lowest y you should have for this point in the middle is half the height. And I think that's what we've got at this point. Now we changed something at the very end of the day, and it didn't seem to work. And I wasn't sure if I went in and typed something in here without thinking, like, hey, you're not even doing you're not on the show. But I think size.height.2, I think this is what we did, but I'll have to check. Okay, so I'm running it in an iPad simulator. You can use iPhone as well. And welcome, Maverick lives here. I thought I'd seen your name before, but it says your first time chat, so welcome either way. Okay, let's see. So we'll get the kaleidoscope going. Now, I think, unfortunately, that it's, by whatever bad chance, it starts in an angle where it's got empty space. And we should get some controls. Okay, there we go. Yeah, so that's empty space. I'm kind of guessing. No. I don't know if I can. We may not have found anything here. I mean, I think that's the center there. Okay, yeah, this is not doing it. Okay. You don't want to shrink the pie slice. Right. You keep the original image and center point within the center. Yeah. Well, the thing is, I want to move around the image so I get that kaleidoscope effect of changing. You know, it's not just for static image; it's changing. Okay. Let me compare this. Yeah, this is where we were before. I don't know. Maybe. Okay, I had two theories for today. The first is I thought maybe what I did there would work, but it did not. Okay, I'm going to kind of semi-put it back. All right, so 2y. Oh, let's use this other function. I think we tried it. This is where we were the other day, and I'm pretty sure it works with problems as opposed to what we just did. And I kind of think the iPhone starts up faster. Okay, well, at least we're starting somewhere. So even here, our starting point is chopped off. All right. But as we go around, we got half a bad circle, but then we get to the full circle the way I want it to. The radius reaches all the way to the edges and all that, and it looks good, except there's neighboring. I mean, like, this stuff is great as far as I'm concerned, but the shrinking and the chopping off is really sucky. Okay, and you can see it kind of going away as it breaks into pie segments and goes. Okay. So I think this is working to some degree, so I'm going to check this in because it's kind of a baseline for us, but revert to Y. Okay. Another comment from yesterday, Mudshark666 suggested, why don't we display the image that we're pulling from and see what that looks like? And I think that's probably a good thing. I don't know if you follow G. Paul Hill, but he has a thing about saying, like, there's a shipping app, which is what you're shipping, and there's a making app, which is what you use to develop it. And there's no necessary reason they have to be the same thing. You can definitely put stuff in. I mean, like, one of the first, I worked at Digital way back when on compilers, you know, and I was very, very struck by how much debugging stuff they had available for them. You know, a compiler usually has these phases, and every phase would show you, here's the tree, here's the symbol table, here's this, here's that, you know, and it just super helpful when you're really buried in there trying to debug it. And we're going to do something similar. So what I'm going to do is, we have these tabs. I'm just going to make a new tab. And we'll just call it, I don't know, experiment. Okay, and the label is experiment, and I don't know, is there I don't know why I sweat over these, but I do. Some sort of, I don't know, beaker or something like that, maybe. Yeah, paper plane will work. Just something to, oh, I'm sorry, you don't have that view. Okay. Let's put it in preview. And I'm going to stop this and bring up the, well, let's do this one. Okay, and I'll just run that. Oh, no, I'll just wait. It's going to take a little extra to start it up next time. Okay, and then let's make an experiment view. And this will be our playground. Okay. And I'm just... I don't know, my system has seemed awfully slow the last couple days. I'm not sure why. Yeah, so I think we're going to... Okay, I'm going to stop this preview. Oh no, there it is finally. Okay, and then I'll just kick this off too, just so we get it there. We have experiment with our paper airplane and just an empty view. All right, so what I want to do is kind of take this and start trimming it down, and get to something we can use. Let's see, how do I get this out of here? Nope. I'll get there. Well, okay, there we go. All right, that's going to take a minute. Experiment view. Okay, so, sorry, copy this. We'll put this in experiment view. And, oops. Okay, we need mirrors. Oh, it got collide view for me? Nice, okay. We'll just let mirrors equals 3 is easier to see what's going on. Okay, and then angle, we're gonna have to track. Okay, so here's this. And geometry, oh, we gotta know that too. Okay, more work than I thought. Okay. And sign repeats, okay. I don't know where we're at on that too, maybe. I don't think it matters a lot. Okay, we'll do 3 because that's what this one is. And the rotation. Okay, so just copying in pieces. Oh, well. Okay, I'll try and work more on the little app on the side here. Okay, so everything's green. Okay. That should give us something. Now I'm going to muck it up completely, so that's okay. My theory is to kind of what you were saying yesterday was I think I can display the photo as it's warped out onto the screen, and then show where the piece of pie is somehow. I'm not quite sure how that will work. Okay, but here's our experiment, and you can see with three reflections, you don't see as much problem, but it's still there. And it was worse on the iPad than on the regular. So again, I'm not quite sure there. Okay, and I know I'm a little sloppy here. Okay, so let's take out this, and let's just take out the collide view, I think, and just show the image. Angle to X, angle to Y. I'm going to comment out this too. Okay, so this should give us the warped image. Yeah, that's sorry. I think that's what I'm trying to do. Okay. Oh, tile it 3 by 3. Okay. Maybe let me read it more closely. Okay. If the image is rectangular, yes. We set the max radius to the small dimension, yes. Then one option is to tile the image 3 by 3 and keep the center of the slice from leaving the middle tile. Yeah, I mean the thing is, I need to be able to move something, right? So, are you saying? I don't know. It seemed like there would be some. Well, okay. I can see there's a scheme with that. If I offset no more than the one tile distance. Okay. Let's see. Experiment. Okay. Let me capture the thoughts there. So one is the current thing we're doing is draw image and show pie pieces, which we haven't done yet. The other idea is tile the image 3 by 3, make sure center stays in middle tile. Okay. Yeah, so here's our image is originally rectangular, more of a landscape kind of image. It's being stretched out vertically just to fit the thing, and I probably will twist that around at some point, but just to see where we are. Okay, so that is how I understand our initial slice is take the center of this and take the minimum dimension, so the width is smaller here, so up to about here, and take this and draw the piece of pie like across that top 2 pieces of corn, or the middle of the first one and the body of the second one. Just don't leave the boundary on. Yeah, well, if I were unfortunately, maybe embarrassingly, almost unfortunately, that's kind of what we're trying to do is keep the center in a certain range, and we're not managing to do it. So, I don't know. I kind of want to understand why I'm not getting it where I think I should. So I think we'll keep going on the pie. If we're kind of, I don't know, if it feels like it's not going anywhere, then I think we'll switch over to the 3 by 3 idea. Yeah, unfortunately, I thought of just like randomly picking places, but it already feels like it moves pretty fast with the rotation. So it's kind of, I don't know, I'd almost like to slow that down or something. But if I move, well, if I do it randomly, it definitely will feel funny. It feels odd when it came close to that. Okay, so let's see if we can figure out what this pie is doing, and then if it's completely off, maybe we can figure out a different way to set those ranges. I don't know. We ran the X angle. We put prints in to check the maximum XY and all that stuff, and it seemed like we had it more or less where we wanted. We actually could use 1 here, but we're checking something. But it's some percent based on the angle times the width times not quite the whole width. So double the mirrors -1 divided by the mirrors says one less mirror width than you have. So this is a percent that's kind of like 90 something, and this is the percent that corresponds to the angle, and then the size dot width. It really should be the minimum of width and height, but you know, just to kind of move it forward. I feel like that should put something in the range 0 to size dot width, which should be okay. Now this one, what the heck is going on? Good question. All right. So we have our image. Okay, so now I want to make a Z-stack. I guess I'll put it here. Okay, and let's take this out. I don't think we'll need that. Okay, but the offsets. Okay, so on top of the pi, I want to put the pi. Let's do this. Mirrors. It's really ×2. Okay. And then I'm going to move this up. All right. And I think I want this to be offset by that. Oh, first straight and then C. Okay. Let's run that. Okay. Experiment. All right. Yeah, that's what I kind of expect. I mean, we got our piece of pi. The angle, I guess that's 60 degrees worth, right? That looks about right. That'd be 30, and then reflect it would be 1/3. So, okay. So that's how I think it's working. And now the moment of truth for this experiment. Build in the rotation. Okay. Now that looked like it moved down. I don't know what the angle is. Let's put a text angle.degrees.rounded .degrees.rounded. Okay. I don't know if we'll get it in the middle or on top. Yeah. I don't know if I can. Okay. Okay, so I don't see angle there. It's gone. Oh, it's off to the side. Okay, so it is the X. My X is too far over. I mean, it's bouncing, I don't know, it's bouncing not as high as I would expect. Yeah, and I probably should squeeze the image vertically too. Why? Okay. Angle+toXY. Let's make this by a half. So it appears to get to over here, but never to the left edge. And then at some point we have to... Yeah, that's a little overestimating, because a narrow slice wouldn't really mind being over there. So I probably should work out the math on that too, but all right. He's still at most half. White space. Oh, what is going on here? Should be half the width to the left. Yeah. Okay, well that's promising in a way. Whoa. That jump is very odd. I mean, that's all in range, except... that first screen suggests to me that it's getting just a pixel or two outside. Let's put +5. I just tweak and see. No, there's something wrong there. Oh, I just can't do it. Okay. And there's just a bad place to start. Okay, I'm going to print. Okay, and now I think our view can at least tell us. Print a result equals result, return result. Yeah, it's not. Okay, that is definitely in range. That is odd to me. Wait, -60? This should be a x coordinate, so -60 is definitely bad news. -200 is even worse. And I'm not getting any positive numbers. And yet, it seems right. How does this become negative? Okay. I'm going to take this just to guard that edge a little bit. Do you think that was messing it up? I don't know. Okay, the result is 5. Probably should print the angle too. Angle is angle dot degrees dot rounded. Oops. Let's get percent too. Oh man. Oh, working angle is just a double. I think. Slice moves. It definitely should not rotate. Oh, it definitely shouldn't change size or rotate. The nice thing about the slice with the vertical, starting from the vertical, we reflect it horizontally. It just makes that initial mirrored images. The rotation comes. Yeah, I don't really rotate the slice. We don't change the size of it. So all these white space issues are definitely reaching outside the boundaries. Oops. Oh, well, interesting to me, this thing looks like it's in a range down to, 5 to 180 or something, which seems good. Okay. Now here, 5. It's getting... Let's look at geometry too. And where's my text anyway? Dot color. Slice moves and assign. Okay. So I'm puzzled. Oh. Is X not going to the right? I mean, this, yeah, slice is 60 degrees. So my coordinates, I mean, just looking at them, right, they're ranging kind of 135-ish, 6, 5, 6, 7. We put the minimum at 5, so I would have thought that would be X0. Maybe I'm thinking of offset wrong. Ugh. If I offset +5, am I... Let's try this. I don't know where I'm offsetting from. Well, that's going to make them negative. That feels funny. Okay, that looks okay. Well, sure enough. I mean, this is... It's not going all the way across. Yeah, so in the mirror, I'm saying 3 mirrors, which means each one's 120, but that's the pi and its reflection. So 60, we're passing in 6 into 360 is 60. Okay. Well, this tells me I don't understand how offset works. Okay, so I think it's... Well, I'm not sure why that initial value is where it is. Okay. The least value... Okay, now I'm going to look at this again. Okay, so, whoops, to this again. So we're going back at most 135. I think it was 360, so that's not terrible. And that's probably also the effect of that mirror stuff. Okay, let's take the, well, we haven't changed anything here, I don't think. They're just a little off. Okay. I'm going to take, okay. What if I take this piece off? So now it's potentially ranging across the whole thing. And I think that's okay because I'm only letting myself go to half the width. But like I said, I've thought I've been okay a lot. Now, I'm not sure why this first 0 is here and then immediately there, and I can't. I guess that 0, angle 6 is already 1%. Okay, and we're, I can't tell if we're over the edge or not. Okay, where is it going? Far left edge, and then it comes up on half. Okay, and it never quite reaches the right edge. That seems okay. Yes, the range of this, I mean, it's half the width times the angle. I could probably flip this around and make it make more sense that way. Half the width times the percent. Okay, so we take some fraction of the whole width, and I don't think we're ever seeing 0. I think this is unnecessary, and this is okay. I don't know if I'm going to screw things up with the mirrors -1 thing. Okay, experiment. All right, well, he's got a little green to his right, so he's worst case. If this is the worst case, it's tolerable. Now, percent, 1%. Okay, bouncing. All right. I mean, that looks all right to me. I could wish the vertical range were higher or something, but could double the angle for the sine and at 180 move back along X. Double the angle. Yeah, I think double the angle. Okay. I mean, this feels reasonable. I thought we kind of were here at some point. Okay, so whatever the angle, we know it's between 0 and 2 pi, so divided by 2 pi, it's between 0 and 1, and up to half the width, and then we're subtracting it. Let's make it, let's subtract it in here and take the subtraction out of here. Okay, that way we can see how it works in the real one. Yeah, I think I got plenty of other problems. Okay, now we're getting back to this. But we haven't proved our y is right either. This is like a totally different section of the output. And he's not. Okay, but on the other hand, he's Well, yeah, I think until we know y is okay, we're not going to be safe. Okay, so let me take this and we'll just return this. I'm going to change this to x. Oops. What I just did there. To x offset. Okay, and we'll get to y in a moment. %1 or 0. Okay, something's funny there. Wait a minute. Percent. How can the result... Wait a minute. Okay. Okay, I did the minus here. Let's make sure I take it out of here. Good. Okay. Percent should be a double in the range 0 to 1. Why am I always getting that? Angles 3, 4, 5, 6. Why is... maybe my angle should be 0 to pi. Rounded is probably throwing me off here. Percent rounded is definitely throwing me off. I just hate to read all the decimals. Okay, just to make sure. Okay. Yeah. Okay, so we'll go around and let's just see what we get. Okay. So angle being bigger than 2 pi? 6.28. Okay, no, that is smaller than 2 pi. Okay, so... all right, so that's okay. Percent's 996, 70s, 30s, 20s, down to zeros. Okay. And that's doing that. Okay. And then in here, yeah, we're getting that like right away. I mean, the slightest, no, it's not the slightest, but pretty quick. Okay. All right, so I trust these pretty much. Okay. So, I mean, that gives me confidence that we are able to put something in a range. Okay. Now the y offset. All right, let's go back here. All right, and let's print result equals result. All right, now this was our mess. I mean, we know this is not going to give us the right range. Okay. Result equals 98. Okay, that's kind of the peak. 0.057. It seems off to me. And we'll just go around and see what we get. Okay, so the range of this thing, we saw some zeros. We started at 100. Down towards 0, back up to 108. 0. 190. Okay, so the problem I have is I want to go across the whole image. I'd like to go all the way to the top and the bottom. Now, I have to keep this point, the tip of the triangle, the pie, has to be beneath the center point. Well, not true. This is back to the thing about, are we working in the squared image or the full stretched image? In principle, there's nothing that would stop me from bringing this thing all the way up to here, basically to 0 to the radius. The radius should be the tallest one, right? Yeah, I think if y is 0, well, no. So if the y we're getting here is the offset, so I think it's adding whatever we did to start at the center-ish. It's going to add the value we came up with here. But if y is 0, well, I guess this result, so y is 0 says don't offset vertically, just stay where you were. So I think the center point is the start. If y ever became smaller than the radius, then we would come off the edge. But I'm sorry, I'm very confused still with what we're seeing. I mean, I think it's staying in bounds horizontally. It looks like it's just maybe touching it. And it's bouncing around vertically. Right? To me, that looks like it's totally in range. All right, but now let's try this. Run that. So I don't know if it's going to take the height minus that or the center minus that. Interesting. That's different. Okay. There we go. That is definitely out of range. Okay. And it's getting close to the right, but there's still green to the right. I mean, I can... Well, I don't know if I want to add to x. All right. If y is 0, the pi would be above the view. Yeah, so I think here... well, I don't know. I mean, it looks like 130 something, 190. I'm not seeing anything more than that. Okay, this definitely goes above. All right, so let's work on that. I mean, in the sense of sine of double repeats times radians. Okay. We have this angle. The number of repeats gives us the up and down bounces. If I divide it by this, it's even. Okay, let's take this again. Okay, so 1 plus sine ranges 0 to 2. If you divide by 2, you get 0 to 1 times size width divided by 2. I don't know why this is. Sorry, where is the origin in the view? I believe the origin is in the top left corner. So y equals 0, x equals 0 over in this top left corner, and then max y down here. Yeah, pi origin, I believe. Yeah, I mean, that's kind of what we tried to do, but if you have no offset, it starts off in the center of the view, whatever view it's dropped in. Now, something is feeling off. Let's get back to. Oh, no, that can't. Okay, I don't think we can see it there. Okay, and then let's look at this view. Why, like, where is that coming? Okay. Get back to it. Yeah, why don't we... That somehow has to be hitting white space, and there's no real white in this image, so it's got to be getting outside. All right. Okay, so I think the y-coordinate, it's the offset going up. So I think it should be limited to the size width minus the radius. Okay, no, it should be limited to the radius because 0's up here. So 0 plus the radius says if I put one right there, I would just be touching that. Okay, let's see. So we want something that's in the range radius to size dot width. Right. So, well, no, that's not right either. It's an offset. So how do I say that? Oh, this 0 upper left corner is just killing me. Right corner of the pizza slice has a value equal to center times radius times sine angle. Okay. Yeah, that makes sense. Yeah, so I think that's the true limit to that should be the true limit to the right. Even, I mean, well, I'm not doing the double, the mirror divided by mirror plus minus 1 divided by mirror or whatever it was. But yeah, so that tells us we should never go further to the right than that. Okay, golly. I wish I had pencil and paper here. It would be easier to work with. So the offset, if it starts at the center, it should be limited to the lowest it should be is radius, or radius plus 1 maybe. The highest it should be is size dot height. Right, so let's let's make x needs to be limited so the x coordinate is less than the width of the image. Yeah. It can approach that close to the side, right? So yeah, you're right. We don't seem to be limiting it. Well, I'm limiting it to half right now. So now I'm not sure that's actually reflected here. Is this at most half? Yeah. So I'm being conservative. So because I limit it to 1/2 of the size and width, the maximum radius, if I took a 90-degree slice, right, would be the radius, size of 1, sine it equals 1. So the radius would be this width, but we limit it to half. Okay, but I could, yeah, center of the quarter of the pie, right? So I mean, instead of 1/2, this really should be like, I don't know what it is. It's kind of like the sine, radius times sine, right? If I assume it's the 0 point, radius times sine is the width, and so I should take that over the size width, and 1 minus that should be my maximum. Well, that's I'm very puzzled by that at this point. Okay, let me double check these. So they're both returning the negative, and content view is using it. I wonder if it's, I mean, that's just, they're taking that offset. I don't know how it gets there. Well, I guess the question is this really what's being used? Oh. Okay. So I'm okay with the x coordinate, I think. I mean, it should be 0 to the half the width. The pi slice, the sine can be at most the radius times 1 is radius, which is half the width. So I'm pretty confident that since it's got its left edge straight up and down, it really is between 0 and half the width. Okay, so it means it's not going to get to the very tassel edges of those corns down there, but it's something. Now the height, golly. But yeah, what we're seeing has no, I mean, other than possibly touching that edge. I mean, and I can do some adjustment to the angle, but I mean, if I did minus 5.0, I would say offset a little less than up to 5 pixels away. And if I run it like that, we'll see that it's never touching it. But if I did 2 mirrors, I don't think I'll let you do 2 mirrors, frankly. Okay, so here, well, I can't see that. I can't see it. Like I'd expected to see that. Let me make that bigger. And 25 is just arbitrary. Circle center x, y coordinates to be limited to min r and max 2r. Minimum r. The maximum. Well, I don't think that max is necessarily right. Okay, so here we are. Okay, so there, and I'm still not seeing visible stuff. Why is that? Am I going the wrong way? Because R is based on the width, with at least in a vertical frame like this, right? So it's got to be R. It really can go further because we've got this whole image that's bigger than the width radius. So I certainly don't want to get above R because then my pi would get outside the range. But I think it's like size width minus R is not going to be the same as 2R. But I've had lots of mathematical theories today, and okay, what's going on there? That's even worse. So I'm going the wrong way. Okay, he's still around. Yeah, I can't get to the edge. I can get up there. Okay. Now maybe I'm... Oh, okay. If I go to the photos, we know we're getting into the white space on top, so we will see some shrinkage. It's much better. There it is. Okay. And I can't get it down to that skinny line I had, so I was encroaching on the edge. Okay. This is fine. Let's go back here. So with x limited to be less than width, min of 0. Yeah, I mean, I think that circle center x coordinate limited to min of 0, and max of center plus the horizontal width of the slice. I'm willing to kind of pin it a little bit inside that, but yeah, that's the true limits. Okay, x limited to be less than width. Yeah, it definitely has to be less than the width. Now so I think we're okay on the x coordinates. I mean, the furthest left one is inside the range by those few pixels I gave. The right one is also inside the range, because we 5 pixels is far less than the difference between sine of 90 and sine of 60. Okay, so it's the sine that is the sine one is still the one that's messing up. All right, so I got to say what it is. All right, so if I take 1 plus the sine, let's extract that. I guess that's this whole thing. All right. Variable. Okay, so 1 plus the sine of these repeats and radians it's the sine from 0 to 2. So if I divide by 2, I get something that is in the range 0 to 1. Okay, just the nature of sine. Always returns 0 to 1, minus 1 to plus 1. Add 1 to that, 0 to 2, divide by 2, 0 to 1. Okay, and then this, to be equivalent, is 2. And I think this is the percent. Well, I should have renamed, but I'm lazy. Okay, so I think that's where we are. Add a quarter to y, it'll fix it. Okay, so I think I gotta subtract or something. It's like I'm adding and subtracting so much, right? I gotta make sure what I want is this offset should be at most, well, I'm not sure. I think it should be at most radius. No, that's not right. Golly. If we're starting from the center, we've got to we got half of size dot height minus the radius, right? Okay, so this is being subtracted. Okay, so okay, I have a percent. That tells me whatever range I want this thing to be, it should be in that. Okay, so the minimum is the center. Size dot width divided by 2.0. Okay, so the vertical center is our initial position, and the lower, well, let's call it min y, is center y minus the radius. Right, so if I start at the center, well, if I put the radius at the top, and I take away, I take the width to the, I guess, to the height, the half the height, minus that radius, that's how much space I can be above the center point. All right, because we're subtracting from the center point, so that little bit is the most I can extract. And then there's a max y. Whoops, whatever that did. Radius. And then there's a max y. Okay. And minus this. Okay. I may need to radius equals min. We've done this somewhere else too before. I want to take the size dot width and the size dot height divided by 2. There's a lot of divide by 2's. Okay, so that's the radius is take the shorter side width or height and half of that. Okay, and that'll be our radius. Okay, and the minimum y is that center value, because that will put us at half minus that value, and the coordinate will still be radius, which is will leave enough room for the radius. Okay, max y, we're going to take the center. Well, it's really the size dot height, I think. If I offset by, no. Oh, gosh. Okay. If I offset by height, so I mean max, what I'm calling min y is the min y offset. Okay, get the name right, that'll help. Okay, so the most I can go this way is this little tiny chunk just below the maximum point of the pi. Okay, the maximum y offset, well, if this is minus 50, the maximum y offset is plus, is minus? Oh my gosh. So max y is size dot height. That's true. Okay. I'm not sure I'm ready to say what the max y offset is. It should be center. Max y offset is center y I think I'm getting my signs messed up. Center y minus max y over 2. think I can just do it like this, inline that much. Okay, the min y offset is, well, right now it's a positive number this distance. The max y offset, I'm going to take the center y minus half the height. So it might be 0. Is that going to work? Radius plus the difference between radius and height. Well, I'm thinking like the tip of the pie can touch that bottom line, the brown with the shadows on it, because the pie is going up from there. So, well, it's going down from there, really. That's why I'm so confused. Okay, so radius plus the difference, max y is height. Yeah, max y, the maximum y value is the height. To make that the offset, to get from the center, 0, 0, sorry, it's not 0, 0, but from the center y, we subtract this, and we're going to add this, so it should be negative. Okay. All right. If I had those things, let's see what the result would be. Well, it's got to be min y offset. Okay. Plus, I think max y offset minus min y offset times percent. Okay. If we're at this should be CG float. Okay. All right. So sorry, if the sign, let's take the percent can go from 0 to 100. All right, so if percent is 0, we get min y offset plus, which is up here, plus max minus min, so that's kind of down here. Yeah, because we got to have that edge times percent. If percent is 100. Oh, if percent is 0, then we just get min y offset. If it's 100, okay, I'm going to run the experiment. Oh, my goodness. So I think one thing is my understanding of offset, now I understand it's negated from where we were, so that gives us something. All right, so I'm going backwards and he's not going far enough. Here he's going high enough. Okay, so I don't think this is right. My final expression is definitely not right. But it looks to me like he's staying in bounds. Okay, so that means this thing should never produce these lines. Ugh, how is that happening? Ugh. Okay, the results minus 100. How? Okay, Okay, I'm going to put something in. Okay. the X. I don't know. We're using this in the production one now because he just takes it and it's there. Okay, so the most, okay, so it kind of gets close to 0, minus 100, 0. It's never positive. That just, well, that seems wrong, and it reflects the fact that we're not getting anywhere near the bounds I want. Oh, okay. It's not implausible bounds, and it bounces up and down 3 times. 1, down, down. Oh, it starts over here. It's down, going up, and down, and up, and down, and up. Okay, upish. All right. The range is always negative and never negative enough. Okay. Oh, golly. I feel like I had to kind of, I don't know. I mean, I remember making lots of little games where you'd get these ranges like this, and yet I'm struggling today to get what I want. I don't know. So I think percent, well, let's make sure percent is right. Okay. Because that's sort of the direct computation we're trying to manage. Percent. Okay. And if we're between 0 and 100, well, 0 and 1, basically, then at least the possible values are right. So I want to check that. I feel bad doing this empirically, but okay. So I'll just go around a couple, 3 times. Okay. So the percentages, I mean, I'm not seeing any ones on the front, just percent equals 0 with some stuff after it. Okay, and I saw 90 something, and I saw some low values, 0 something. Okay, so the percent is correct. Good. Okay, so that means the offsetting is wrong. Hey, welcome, Crypto Monad. You get to watch me flounder around with math. And not that hard of math. Okay, so we're trying to make this thing bounce up and down 3 times all the way across the height of things. The challenges are the y equals 0 is up here and y equals max is down here. So the whole thing is a bit backwards, and we're trying to get the offset from the center point up. Okay, so center y. Okay, I have a cheater way to do something. All right, let's start here. Okay. Now this min y offset, that should be the value that gives us the maximum position, right? Is according to my theory of what min y is. I don't know if I rotate any. Yeah, so I'm getting zeros. Min y is center minus radius. That's a little weird. Okay, we got radius. Center y is not width divided by 2. Okay, it's height divided by 2. Now that's one thing. Okay, so this should be further up the screen, almost maybe barely touching the top edge. Okay, and let's add a buffer on that, +5. And I've gotten these pluses and minuses backwards before, so I'll run it again. Yeah, backwards. Okay. And then over here, well, we know that's outside the edge. No, just a little. But yeah, that one's almost there. Okay. And we're still off base somewhere. Oh, but that's okay because I have that. Maybe that's what that is. All right. Run this again. Notice result is different now. It's not 0. Percent was 3.28. Whoa. Oh, I missed that. Did I run? Okay, he's in bounds. All right. So that's fine. Okay, now it's... So if percent is 0, min offset should be up there at the very top. All right. Now, if... Oh, but this is... Okay, is this still... Let's take... Well, let's see what happens. Okay, so I got Y. I'm still on the hard-coded one. Okay, let's run this. Now, max Y offset... His center. Okay. He's center minus the height. Well, center, oh, that's 0, right? Center is the height divided by 2 minus a touch, but it's basically the height. So center, if this becomes 1, these two cancel out, and you're left with max Y offset. So I think that should be minus... I think that should be this. Minus size height. Okay. And then that would be plus the center, which is size.height. Okay. Let's try this. Maybe I better print that back in. Okay, and it looks a little lower than the center to me. All right, he's going up, way up. Oh, and he's going all the way down. Okay. And that... Oh. What is going on? All right. So is it possible? Okay. I'm worried about that percent thing. So let's do this. No, let's do this. If percent is less than 0 or percent is greater than 1.0, let's print percent out of bounds percent. Okay. And I'm just sweeping around trying to find that percent. Now, I'm going to put a bound on that lower position too. Okay. Well, I didn't see any percents out of bounds. So I don't know what we saw there. But I'm still puzzled. Like, how is this? Well, we can do the same thing, right? I mean, we can put, I mean, if, well, let's take adding this in and out so many times now. Assert result is greater than or equal to 0 and result is less than or equal to size dot width. That's my x coordinate. And return result. Okay, so I'll just let it blow up if it's out of range. And then I'm going to add the same thing here. This one's trickier though. If offset is less than minus the height, offset result, it's got to be greater than minus the height. Well, and this is not what my result is. It's really this negated, and this is there. Okay. Result, well, the easy assert is it's greater than or equal to 0, and it's less than or equal to result.height, except it can be negative. It's greater than or equal to, this is really, oh gosh, this is where I mean, min offset is intended to be that. Okay, and let's print those two. Just to get some visibility into our thing. Min y offset. Max y offset. I don't know, the mins and maxes maybe a little off. And I think if I calculate these two wrong, then I don't know. Greater or equal, I think it's really less than or equal. Well, let's get the prints and then we'll do the asserts. Oh yeah, we can check that one too. Although again, I don't see how it would, but okay. Boom. Okay, my X failed. Minus. Oh, I'm backwards. Is it? How did I get so many values before? Okay, because the result is negative, right? The most negative it can be is 100% So minus, all right, min x is minus, well, minus size dot width, whoops, minus size dot width divided by 2.0, right? That's really half times that. Okay, and the max x is I guess it's size dot width divided by 2.0. But maybe that plus 5 is going to throw it off. I'm going to take this off for now. I know. Yeah, okay. I know they've changed things enough here. So result is greater than or equal to min x. And less than or equal to max x. I don't know if that's right. Actually, there's no way it's right, right? The worst it can be is 0. Because we don't offset past the center. Okay. We'll have to change that. Okay. So this is 0. All right. Let me make sure my x's are right. Well, other than possibly that border, which I don't think is really going out the range, outside the range. Okay, my x's seem to be inbounds. Okay, now what about my y's? Min 153, max 355. Now, this is looking right, isn't it? I mean, it's going up all the way, minus that 5 pixel difference. And then down here, it's basically at the bottom. Okay, so there's 354. Yeah, you can see my mins and maxes. It's between 153 and minus 355. So my max is really the min and vice versa. Because of all these flipping signs. Okay, and then what does that look like here? How is that still happening? Okay, that's a puzzle. All right, let's get the angle in here too. Well, the percent. Or is it self dot degrees? We can at least see where that's doing it. Oh, man. Okay. So, we got some angles going in degrees. Is that a 10-degree angle? Why are you not? Okay, there's... So, in this range... I mean, there's 35. Well, there's kind of my 0. right? So 0. Well, I notice the angle is backwards to how I think of angles, for one thing. Okay, but what is the angle here? 0. Now that's suspicious. Let's make this 30. Now theoretically that shouldn't change what's happening, but it should change where it's looking. Oh man. And my dumb chance picks the wrong one. I mean, that looks like minus 30 to me. They're saying it's 0. And then do I get one at 120? Minus 200. And then back towards 0. Okay. Let's make this 87. Just trying to get some random thing that will be in a good place for us. Okay, good. All right, so I would call this 0. I would call this minus 90 or plus 90. Well, I would call it minus 90 or plus 270. They're calling it 88, so I've definitely got something a little weird. But I don't think that's the issue. The issue is at the 30 degrees to about 0 degrees. Oh no. Okay, around 30 degrees, it is nothing. Okay. Angle is about 30 degrees. Okay, let's run our experiment one. See if we can get this down to about 30 degrees. 30. Okay, I think let's take a break. 3 or 4 minutes, and we'll come back to this. What I'm seeing is the thing on the right. At last, our experiment looks like I expect it to, as far as where I wanted to grab points in the picture, and I'm glad that's true. But the thing I'm not seeing is if this stays in those bounds, how are we getting empty space on the other? So that's the puzzle to solve. I think we'll have to figure that one out, because there's just something really wrong on it. Maybe the assertions will be enough, and we can add those to the y's as well and see what that gives us. All right, see you in 3 or 4 minutes. All right, welcome back. Let's see. Does that have something to do with the image view where the picture is loaded? And is it okay to brainstorm? Yes, definitely. So, I mean, I guess it could. We have less. I mean, we know. I mean, this part seems the same, right? Image resizable offset inside the stuff we're doing. Where's our experiment view? Well, this thing never showed up. Image resizable. And then we're doing the pi offset. That could be related. Let's flip these. I don't know if this is related, but so I think what we're doing here, right, we're offsetting the image by these amounts versus the pi. Well, let's do it this way. Let's make our experiment view do that. Okay, that's more like our experiment view, I think. Image resizable offset, and then here's the pi. And we're just stacking it on, and now the pi should just sit there in the middle and not do anything. And I think you're right. We're going to see something's going to go like, Okay. Try and get to a full-sized there. All right. So that doesn't look like half the image to me, and it also seems to have moved. Like it's offset already. Why is it offset? Oh, okay, because I made... Well, okay, that's okay. We'll see. All right, there you go. Thank you. Okay, so we're seeing lots of empty space and then maybe a line there. I think I can do a stroke color red. I don't know if I have, okay, yeah, that's, oh. Is there anywhere that's safe? Okay, there, a little bit. Okay, so now I want to flip these angles. I'm just going to do it down here for now. And we know it's already messed up. Okay. All right, that's all right. Well, no, that looks consistently in place to me. All right, but this one already looks wrong. It's chopped off. Oh, but we're getting different. Okay, okay. It's much, 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 much less chopped off. That's that. And we're definitely seeing parts of the picture that we didn't see before. This is nice. Okay. Golly. Now, I don't know what that means. Yeah, I really don't know what it means. Although maybe there's just like, well, I can't adjust anything other than this, which is pretty crude. Okay, I mean, it looks like it's got a boundary. Oh, that could be a hair over. I mean, it's either right at it or a hair over. That's the blue. This seems okay. Okay, that one's limited. I mean, we could limit it by 90% each way or something would probably help. I don't feel like I'm getting the center of the picture as much. Oh, there it is. Okay. Well, Did I leave my X? Okay. Well, this is max X. Okay. So my X should be... I don't have... Was this +5? I think that's going to push us outside of X. Result with... It's still puzzling. Right? I mean, that's way... Boom, assertion failed. Okay, and what's result? It's going to be like 5. Yeah. I think that'll be the same way. I mean, that'll make it okay. I'm worried about Y. I guess the X, yeah, we're standing right off the edge. And not a problem on that side. I guess I want to do the same thing for the Y. But we know here, well, where is that looking? It must be up here. Okay, so I think X's limits are okay. That stayed in range. Okay, I'm going to take this out. And this out. I mean, I think we've done so much change at this point, they don't really help us get backwards. Okay. All right. So, okay, this is still, and that's, well, that's 30, right? Content view, I think I changed, oh, it's 87. Make sure that, yeah, now down here somewhere around 30. Now that's suspicious. I don't know how you'd get that. There is a little white in the image, but I don't know if it's that pure white. Man, that's nice, nice, nice. Minus 30. What was that? Minus 150. Right, that's suspicious there. 30. Oh, Minix is now at least... Yeah. Am I getting? Maybe. Well, that's my concern. Is it doesn't seem to. Now I don't know if there's. It may be. One possibility. this, like this image, it's all in a tab view. So I wonder if it's just being squeezed that much, you know, because I think the tab view is going to reserve this space down here unless, and so our experiment view, well, that's kind of weird too. I guess it's bouncing around, so I got to look at, yeah, it's going down to the very bottom and then some. Okay, I mean, we're trying to get to that top. Right there is suspicious. Yeah. So when I do this, I mean, what? What's the... There's something that says it gets to go, the border, it can stretch out across the thing. Well, I used it in Calc somewhere. Scroll content background hidden, no. This. Ignore safe area. Let's see if that... So our experiment, we definitely go down below the tab view and above whatever. We don't care. All right, now here. Oh, interesting. That we've never seen. Sorry, angle 10. Yeah, I'm not sure if we can quite relate the two. Here's around angle 0. Okay, but I'm getting something weird here, right? Because that piece right there. Huh. Now that's even stranger, isn't it? It looks like it's got the rounded curve, and it looks like the right size to me, because whenever it expands back out, it comes there. So it's almost like it's chopped off before it's reflected. I don't know what this would have to do with that. And the worst part to me, in some ways, this static view is just kind of a simple starting point view. Even it makes a nice enough picture, but it's not really what the app is intended to be. I'm going to take this back out, run this again. See if I can get a funny... No, I'm not getting that. So it's something about that safe area. And we're not triggering our assertion failures, like this white spot. Where'd that go? That's weird. Angle about 30. I don't even know how that can be. I guess that would be if the nose of the triangle is below the bottom of the page. Okay. I wonder if the order sometimes matters. It makes me also wonder if we should we be moving the pie instead of the picture. I don't have a good answer. Okay, now I'm not getting that weird piece sticking out. So, okay, we're getting a little stuff around the edges. Oh. Is it? I don't know, it looks pretty symmetric to me. Unless you're talking about before when it jumped out. Oop, there's something. Is that? Yeah. There's a little weird artifact there. It's occasionally slower. Oh, it's really weird. Okay. Let's take this back out. See if we get these artifacts. Yeah. Well, I'm going to have to go get drunk after this. Top triangle is moving differently. Move slowly. Yeah. Okay. All right. So it looks okay to me. Now we're shrinking. I don't think I'm seeing anything weird in it without the ignore safe area. That part I don't like. I love this. And this is just a random photo, you know, so it's very promising to me that, I mean, it's just a photo with some colors in it because it was a picture of fruits and vegetables. Okay. Okay, so what this... Well, what I want to do... Gosh, I feel our numbers are so close, you know, that it's just so close. But yeah, CryptoMonad, I think it was your notion that the pictures were not being treated the same in the two screens. Yeah, I think that's what's going on, right? So, you know, really what I want to do... Well, what I'm thinking is, like, what I want in a way is I just want to pass the image in and then let it put it onto a view and then manipulate it. Now, I don't know if that's going to be better or not. I know it's what I thought I was doing, and I definitely thought I was moving the pie and forgot I had actually been moving the offsets on the image. But like, I don't really want I don't really want to put the whole image anywhere, right? I mean, the point is to do this, you know, to take a slice of it in the background. Oh, no. Now, I don't know if I can get an image to like auto rotate. This may be a different question. Yeah. Oh, orientation. Oh, not quite what I'm after. Okay. All right. Okay. I don't know. Yeah, that's a good question, and I don't know the answer. You would think there'd be a way, I guess. I mean, in a way, that's I mean, I hate to pass in all this stuff, but like the kaleidoscope view, if it just took, I don't know, if it can take an image, I'd like to rotate it so it's, you know, landscape or not, you know, landscape or portraits to fit the best dimension fit on the screen. And then, I don't know. If I can render that and then use the offset on the pie, that would be more reflective. I mean, I think barring the very bottom tip, like at the maximum, it's got that buffer we gave it 5 points. I can do the same thing on the bottom. I'll get this going. But I mean, to me, it seems like it's in the image the way we'd want it to be. In our experiment, we did that before. Right here, I'm doing this. I'm thinking, like, what if we did this? Probably better stroke it after. I may not be able to. I can't remember the rules. It's okay. All right. I don't think that ran. I don't think what we're doing is wrong per se, but it's okay. Let me think. If the top is cut off, right, that sort of means the circular part of the pie is cut off, so that means it got too high on the image. Man, it's weird. You can see faces in this. Your mind just finds them everywhere. But that definitely see a gorilla face with a nose and mouth there. But at any rate, this chopped off here tells me that the triangle got too high. It got outside the bounds at the top. And the nose, the white in the center, I think that could happen if, yeah, because we had white in the center with square edges or flat edges. That happens when the nose of the image is outside, so it went down a little too low, which fits with our idea that this content view image is different because it's got stuff in it, and this button, yeah, that. Well, let's make that a Z stack. But I think we're going to find that it's okay. Well, that's something. Yeah, we're still getting that. Okay, so that stuff is too far on the bottom, and these are too far on the top. And if you ever, I don't know. Okay, put this back. All right. Yeah. Well, I mean, I can make up a number. I mean, yeah, let's do that and see if we can get at least the look we are after. Well, it's minus 0.9 times result. All right, but nothing tells me, you know, as I add more things and all that, it's going to shift it again and be a problem. Whoop, lip just a little. Okay, let's. Yeah, I think we finally have X correct. Yeah, so I think I mean, this is interpreting, but I think because it looks like the pie piece is flat on top, that tells me it went up too high, and got chopped off the rounded part. If the nose gets cut off, then we see that in the center. If we're too far to the edges, I think, well, I don't know. I think that was more where we had those just intersecting lines, and then they sort of worked their way to being separate triangles. Yeah, so the tabs make a difference. I'm just arbitrarily choosing 75. Like, it would be nice to have this thing rounded at all times. Okay, so for whatever reason, you know, the picture gets at least 75% of the space, or some, whatever half of 75 would be. All right. Well, that is progress in some sense. I mean, it's not mathematically quite justified, but yeah, 2y returning 0 is incorrect. Do we ever return 0? I don't know. Oh yeah, we do. We go negative. Negative is sliding up past the thing, but past the center. All right, let's push this at least. Okay, so we've a better 2y, but we have to scale it to allow for the tab view on the main page. Okay. Now, I know I'm getting distracted because I do this draw image and show pie pieces. Okay, so I would say what we did. Okay, 2306, 10.3. All right, we set up an experiment tab, and we empirically, that's a nice word. Empirically reworked angle plus 2xy to keep pi in bounds. Then we realized we're moving the picture, and the tab view changes the picture size, pushing us out of bounds on the main view, even though the experiment was okay. All right, I think that's where we are. Get the height of the tab view and subtract that from the view height. Yeah, you know, that's a good idea. I mean, Geometry Reader. I've got the tab view in the Geometry Reader. What if I pull it out and only read the angle on this. Okay, so tab view. Let's put it. That's our geometry reader. Tab item. Text. Da, da, da. And then we need to get rid of one of these. No, I messed up something. All right, so tab view goes to the bottom. Okay. Geometry reader goes there. Okay, that's not quite right. We want geometry reader to end. Well, there. Now, experiment view has its own geometry reader. That's interesting. Okay. Let me reformat this too. Okay, this was our 0.75 that we empirically did. Okay. And then experiment view should still be, haha. Okay, he's no longer in the geometry. Oh, he's no longer in the tab view. Oh, and I changed it back to the wrong thing, I think. Yeah. We know it's the image being manipulated. Can we get the height of the view and subtract that from the... Yeah, maybe there's something we can do on that line. Okay, that's... It doesn't go down to the edge, doesn't go to the top or bottom. I mean, it's missing some stuff, but that's normal. Okay, and now this... Well, with the 0.75, it's right. Okay, let's take this... put geometry reader on the Kaleidoscope view only, not the tabs. All right, now I want to take off that 75 and see if we need to scale it like that anymore. Okay, let's just return minus result. Oh, just the tiniest bit. Now, oh, golly. The code's public. Yeah. Okay, I think I missed some comments. It's the why that's wrong if the top and bottom. Yeah, okay. Tabs make a difference. 2y returning 0 seems to be incorrect. Never mind. Okay, code is public. Yeah. It's GitHub is wwake, I think. You get the height of the tab, you subtract that from the height. So something is just so slightly off. Isn't that just weird? You know, maybe it's that 5 is just restricting something in the wrong way. It's so close. Okay. And unfortunately, this thing with the flipped coordinates and the offset is going up or down or whatever, you know, it's like by the time I get there, I just don't know if I've got one too many signs and negating each other or what. Sorry. Running again. It's that one section, so it's, I don't know. It's by the corn. And there's the tomatoes. We're over by the corn. And dark green. I've got the image here somewhere. Yeah. corn with dark green. I mean, there's some dark green. That light brown is the counter. So maybe it's kind of like there. And that would say the Y. Okay, let's go back to experiment. That's not it. That's not it. That's not it. Maybe there's some point where it is. And also, again, I kind of don't trust the angles that maybe, because we have to wrap them and stuff. Yeah, it's so close. But we do have on the bottom, we are allowing it to get too close. Size height divided by 2. I'm going to say minus 50. Now that may throw something off, but that's the max Y. Okay. It's just slightly there. Oh, okay, it's plus 50. All right. Yeah, the image is flipped and it's awkward. I don't know why. Why is it flipped? Wait a minute. That's really kind of weird, isn't it? Oh, I don't think it's flipped. I think it's just stretched. So you got blue, tomatoes, lettuce. So the top is tomatoes, limes, and corn. Or I don't know what that is. Oh, you're right. It is flipped. Whatever that. I don't know if that's a red onion or what. Why would that be flipped? Oh. Okay, so if we show image with no offset and no pi, right? That's the image demo we get. And it is flipped. Okay. Scale effect X one minus one. Oh, I want to take this stuff off. Remember that again. Or so the radius is correct. It's calculated depending on the path. Yeah, so rect is basically should be the rectangle of the view it's getting. Yeah, the top is the wood. Well, I think, was there wood on the bottom too? No, just the top. Okay. Yeah, that looks correct vertically, although stretched. What I'd really like to do is rotate it. I don't know. Can I rotate it? Rotation effect. Angle. Angle degrees 90. I don't know if that gives me positive or negative. Remove angle. Okay. Trying to get the corn on the bottom. No. And it even looks weird. Well. No, that's not what I want. Oh, let's Oops. Let's do that slight change. Oh no. So it stretches it, and then I get to try and rotate it, but it doesn't know how to. Gah. Okay, that's not worth it. Isn't that weird? Like, how to rotate a view. Well, it's doing something, but it's not. Yeah, I don't know. It's unfortunately, I guess image has the modifier for resizable, but view does not. So, yeah. Golly. Effect. Degrees minus 90. Okay, I'll run it, but oh, it's not gonna. Well, and I want this up there too. All right. Has no member resizable. Okay. Well, we'll just see what it looks like unstretched, but I don't think it's going to work. Yeah. Okay. Well, that can use some work. Let's put it that way. I think this is okay. I mean, it changes the view a little bit, but it flips it back to the way we want to see it. Okay, so tomatoes and red onion at the top. I mean, that does look okay. It's stretched, but I don't think it hurts us. I mean, we don't really care. We just want the picture to be filling the frame so we can get some stuff to look at. Okay, we get it a couple times. So it's something to the sine wave stuff. So it is the y coordinate. Yeah, okay. Sorry, so Swift. So if you want to know the dimensions of a thing, an element of some sort, this geometry reader wraps around what you want to measure, and then you can get the size. So geometry records like the width and height and stuff like that. So that's the size coming in to our function is the width and height of the view. So it should be the whole area we're displaying, and like we changed it to only pick up the kaleidoscope view, not to pick up the whole screen. Okay. So yeah, with just a couple of minutes left. Let's make sure this is formatted. It looked a little weird. Okay, that's a little better. All right. Well, my conclusion is Y is a little bit off yet. Okay, let's look at this again. I think we got the white space to go away. I don't think we see any anymore. Okay, so we've apparently doing the geometry reader on just the thing we were after does help us on that white space in the middle problem, but we just have that little spot where the top is too close, I guess. Okay, and I guess we will pick up there tomorrow. I mean, it's close, and this seems a little more than it was. If I can find a mathematical reason to scale it, I would be happy to. But I suspect the mathematical thing is there's something still different between how we're displaying our image in the main screen versus this screen. So we'll leave it there for tonight. Sleep well, and we'll hopefully both come back with, or all come back with, lots of ideas. But thanks everybody for joining. I appreciate others speaking up as well as Mudshark666. Always appreciate your interactions. And we'll be back tomorrow, 2 to 4:30 p.m. EDT or 6 to 8:30 p.m. UTC. Have a good evening. Take care. Bye-bye.